Code to Enhance Learning presents the CEL video series for beginners to learn various coding concepts. Through this video series, we aim to introduce you to the world of coding using the Scratch coding platform. Hello everyone, I am Ayush Sankaran, an enthusiastic coder, CEL hackathon participant, and a volunteer for CEL. I am going to be introducing you to the concepts of programming using the Scratch platform with fun and simple projects. What are we waiting for? Let's get started! Welcome to course 1 of the series Coding with Scratch. In the 9th episode, we will learn to create a busy street with repetitive actions. Let's look at the demo of the project. When I press the green flag, we will see the busy street come to life. Please make a note of when each person/animal's entry happens on the stage. As you could see, the entries of people/animals happen at different times once the project starts. This is how our project will work. In this session, we will make an animation of a busy street showing repeating actions on the street. Let's recap the concept of loops. A loop is an instruction that repeats a specified number of times until a specified condition is reached. Repetitive tasks are common in programming, and loops are essential to save time and minimize errors. Let's think about loops which we can use in a busy street. It could be a person walking down the street. It could be a bird flapping its wings while flying. It could be a speaker while playing sounds. It could be a person riding a bicycle. It could be constant changing of traffic lights. We will see how to code some of these actions in our project using loops. Before we proceed further, let's learn about a new block called the GoTo block. The GoTo block helps us to go to any particular location on the Scratch screen. We can see the Scratch screen here. If we want to place the bird at this location on the screen, the GoTo block will help with that. Let us understand this a bit further. The horizontal line which divides the Scratch stage into two halves, top and bottom, is called the x-axis. Similarly, the vertical line which divides the stage into left and right is the y-axis. The center point where both these lines meet has a value of 0 for both x and y. On the x-axis, the last visible value of the right side of the stage is 240. Similarly, the last visible value on the left side is minus 240. So if I want to mark the value 100 or minus 100 on the x-axis, it will be here. Similarly, 200 and minus 200 will be here. As you can see, the x values increase on the right side of 0 and decrease on the left side of 0. Similarly, on the y-axis, the top and bottom values of the screen are 180 and minus 180. Now if we want to mark 100, it will be somewhere here. As you can see, the y values increase as we move to the top from 0 and decrease as we move to the bottom of 0. Now that we know the two axes, let us try to find some locations on the screen. Take a look at this block. The first value of 150 is the x value. The second value of 120 is the y value. We will see where 150 falls on the x-axis. It will be somewhere here. 120 on y will be somewhere here. The meeting place of these 2 points will be our approximate location. Let us check if we are correct. As you can see, we could point to the correct location. Let us try one more location. Here the x value is 191, which will be somewhere here. the y value is minus 142, which will be in between minus 100 and minus 180 approximately. So our location will be somewhere here. Let us check. Once again, we have the right location. This is how the goto block helps us to go to particular locations on the screen. Let's look at how we can do abstraction in our current project. We think about two things. One is what will happen on the stage, and the second is what sprite and backdrop we need. When we think about this, we understand that we should show repeated actions like a girl walking, a bird flying, speaker playing music, and a woman pushing a cart. Next, when we think about the sprite and backdrop needed, we understand that we need person sprites, bird sprite, speaker sprite, and a cart sprite. Some of these sprites will be available on Scratch, and some we will be drawing on our own. As you can see, abstraction has made the project really simple to understand. Let us now see how to code the project on Scratch. This is the Scratch offline editor where we will be coding our project. I will rename my project as a busy street. Next, I will delete the cat sprite. Then, I go to backdrops, and from the outdoors category, I choose the boardwalk backdrop. Next, I will add my sprites. As I add each sprite, I will write the codes for that sprite as well. I want two boys standing on the stage, so I go to choose a sprite, and from people category, select D. I reduce his size to 60 and place him on the left of the board. If you see here, you will see the X and Y values of D's location on the stage, which is what we saw when we learned about goto blocks. Next, I go to the sprite library again, and from people, I bring Devin. I will reduce his size to 60 and place him near D. I want Devin to look at D, so I go to the costume of Devin, and in the first costume, I click on flip horizontal. Now you can see that Devin has turned to the left and is facing D. I come back to the code tab. I won't add any codes to these two sprites as I don't want them to do any actions. Next, from the sprite library, under music category, I choose the speaker. I reduce its size to 60 and place it on the right side of the board. Next, I go into the costumes of the speaker. I see that there is only one costume here. I want to change the costume of the speaker to show music playing. I duplicate the existing costume, and in the second costume, I use the line tool to draw lines like this. This depicts music being played. Now, when I interchange the costumes, it looks as if music is being played from the speaker. I go to the Events tab and bring When Green Flag Clicked. This is a special event in Scratch, which actually means when the program starts. So if you want anything to happen right when the Scratch program starts, you will use this event. I bring the switch costume to block and choose costume as speaker 1. Now I want to continuously keep changing the costumes for some time. So from controls, I bring the repeat block and change the number to 50. Then from looks, I bring next costume block. Then I wait for 0.2 seconds. Next, I also want the speaker to play a sound continuously when the program starts. I again bring the event when green flag clicked. Now from controls, I bring the forever block. Whatever we put inside this loop will work till the project ends. I bring the play sound until done block and choose a sound from the list. Let's test what we've done so far. When I click the green flag, you can see the speaker changing costume and also playing music at the same time. Next, we will code a bird flying across the stage. I go to Animals and choose the parrot sprite. I change its size to 40. Next, I will write the code for the parrot. In the demo, we saw that different sprites appeared at different intervals after the project started. So, from events, I bring the when green flag clicked event. Then I hide the parrot. Now I wait for 2 seconds and then show the parrot. Now I drag the parrot to its starting position on the screen. Here I can see the X and Y values of the parrot's location. From motion, I bring the go-to block, which has the same values to set the starting location of the parrot. The parrot needs to fly to the other end of the screen. So I bring the repeat block and set its value to 45. We can always change this value if the parrot doesn't reach the end of the screen. Inside the repeat block, I add move 10 steps block. Then I bring the next costume block from looks. Then I wait 0.15 seconds when the parrot reaches the end of the screen. When the parrot reaches the end of the screen, I will hide the parrot. As you can see, the parrot appears after 2 seconds and then flies to the end of the screen and then disappears. Next, we will have a person walk from right to left of the street. From the library, I bring the Avery walking sprite. I change her size to 70. When I check the costumes of Avery, I see that there are 4 costumes, interchanging, which makes her walk. To make Avery walk, I bring the event when green flag clicked. I hide Avery and then wait for 3 seconds. As you can see, Avery is facing right. To make her turn left, I bring the point in direction block and set it to -90. But wherever I change the direction of the sprite, it tends to invert. To avoid that, I bring the set rotation style left-right block and put it before the direction change. I drag Avery to the starting point and note the XY values of her location. From motion, I bring the go-to block with the same values set to her location. I need to make Avery walk to the end of the stage, so I bring the repeat block and set the value to 45. I bring the move 10 steps block. Then I change the costumes by adding next costume. Then I wait 0.15 seconds. After she reaches the end of the screen, I hide Avery. We will test the code by clicking the event. After 3 seconds, Avery starts walking. Once she reaches the end of the screen, she disappears. Next, we will code a girl pushing a cart on the road. I go to the sprite library and bring the Avery walking sprite. I reduce the size to 70. Then I go into costumes. As we have used the same sprite as before, I am going to change the color of her shirt to make her look different. I select her shirt and change its color to yellow. I make a note of these color codes so I can use the same color in the next costume as well. As she's pushing the cart, I want both her hands in the front, so I delete her left hand. I select her right hand, copy paste it, and move it to the right place. I send it behind the shirt using the back button. Then, using the erase tool, I erase the extra part of the shirt. I go to costume 2 and select the shirt. I hold down the shift key while selecting if I have to select multiple parts of the shirt. I change the color to the same yellow using the codes we noted earlier. I use the outline tool to draw the outlines. I don't want her hand to face down, so I delete the hand. Then I go to costume 1, select the two hands facing front, copy them. I go back to costume 2 and paste the hands. I align them and send it behind the shirt using the back button. I align the remaining part of the image as needed. When I interchange the two costumes, you can see her walking. I go to the code tab to write the codes. From events, I bring green flag clicked. Then I show the sprite. I move Avery to the starting position and fix the go to block. I bring the repeat block from controls and change the value to 45. Then inside, I put the move 10 steps block. Since we will be using the first two costumes, I bring the switch costume to block and choose costume A. Then I wait for 0.15 seconds. I duplicate these two blocks and change the costume to B. When she reaches the end of the stage, I hide Avery. I test the code by clicking the event. You can see Avery walking with her hands in the front. Next, I need to draw a cart. So I go to paint a sprite. I choose brown color and draw the top part of the cart right above the center point of the drawing screen. The cart should also be aligned horizontally with same space in the left and right. Next, I use the circle tool to draw the wheels. I remove the fill and darken the outline. I copy and paste one wheel to create the other. Using the line tool, I draw 3 spokes on each wheel. I need to add some fruits. So I go to the sprite library and bring the apple sprite. I go to the costume for apple. I select the apple and group it. I copy the apple. I come back to the cart sprite and paste the apple here. I resize it and then create copies of multiple apples. I follow the same steps for banana as well. Now I need to create more costumes to make the cart move. I duplicate the costume. I use the reshape tool to move the spokes a little to the right. I create one more costume and repeat the step. When I interchange costumes, it looks like the wheels are rotating. Now, I will delete the apple and banana sprite I brought in. I go to the code tab. I reduce the size of the cart to 50. Then I drag the cart and place it near the girl we created earlier. I write similar steps as I did for the girl. Once done, I click the event. The cart moves quite fast compared to the girl. So I change the repeat to 90 and move steps to 5. Now I will test the whole project together. As we can see, the busy street has come to life. Now that you know how to use loops, you can try all kinds of projects with repeating steps. For example, you can get a car or bus to move in a track over and over again. Now that you know how to draw your own sprites, you can draw your own vehicle as well. Let us look at the code on the right. Which of the below loops should we use to reduce the lines of code if we want to make a square? Please pause and try to answer. Since x is positive and y is negative, the answer option is C. Hope you got it right. In the next episode, we will make a car moving with wheels rolling on the road. This is Ayush signing off. Bye.